Hi folks, good morning. Good morning. What a fantastic turnout for 7:30 a.m. Pacific time. Wow, this is great. Yeah, I still kind of feel a little bit on Pacific time this morning, but it's great. It's wonderful to see so many faces here and a lot of people that I know. Throughout the years, there's always a great event. I guess it's more kind of like a bunch of friends coming together than some of the other events that we do throughout the year. I'm Christiaan. I'm a product manager at Google, and today I will be talking a little bit about phishing-resistant authentication. Who here has seen my presentation last year at this very event on the topic? Okay, not too many, so I could have just reused those slides. Bummer. All right. So we're going to show some of the kind of, I guess, golden threads that's weaved throughout the work that we've been presenting for the last couple of years on the topic. Yes, you'll be hearing about security keys. Yes, you'll be hearing about FIDO. WebAuthn, kind of a new addition here to the little word salad. And then we'll also be talking about some of the newer things, and Stephen will be wrapping up for us with use cases. So it's kind of like going to be a dual presentation here this morning. I'll start off. I'll do the first half of the presentation and then Stephen will come up and talk about some of the more interesting use cases towards the end. So I'll kind of be doing the primer, and then Stephen will be talking about use cases. So without that, let's get started, right? So as I said, presentation will be divided into three segments. Segment one, passwords aren't enough. A little bit of background on like why are we even here? Like why do we need to do something about the perceived problem with passwords? Industry solution to the problem, multi-factor authentication. We're going to talk a little bit about MFA and how MFA is a spectrum of assurance and not just one, single silver bullet that's supposed to save everyone. Although sometimes we do think that it's that way. And then lastly, Stephen's section where he'll talk a little bit about WebAuthn. So that's roughly the way that we'll spend the next, I guess, almost hour with you folks. I don't think we have content to completely take us through 50 minutes. What we rather wanted to do is have about 40 minutes, 35, 40 minutes worth of content, and then leave the last maybe 10 minutes or so open for Q&A from the group. And it seems like we have a fantastic, well-attended group here, so hopefully that'll be interesting for folks to hang around for that. So first off, passwords aren't enough. If you've seen any of my talks before, I usually start with this. There is a problem, right? Passwords are broken and we need to do something to fix it. Let's throw out some numbers. 3.3 billion credentials leaked in dumps. So what we do at Google is we're pretty good at indexing the web. And we set up our search crawlers to actually go look for password and username dumps. These are not that hard to find, kind of standard formats. You can work around. If you can index websites, you can also set yourself up to go search for these things. And what we found was 3.3 billion unique username and password pairs on the web, just ready for the taking. And these aren't things that necessarily came from, company A being breached or company B being breached or whatever. They certainly didn't come from Google. But these are credentials that just all around the web because of data breaches that have happened in the past, right? There's a big data breach, 250 million username and password pairs gets breached. These things end up online somewhere. They start to get disseminated, and before you know it, there's multiple copies of these databases all around. And because humans, we are human, we tend to reuse passwords. It basically means that a password that was harvested for, xyzpets.com, maybe that same password works for that user's Google account too, because they end up reusing that password. So 3.3 billion of these leaked credentials found. We found when we started correlating the dumps and the data from one dump to the other, that there is about a 17% password reuse rate. So in other words, if we discovered for a certain email address or username, password tuple, we discovered it over here, chances are that we'll see that exact same username password tuple end up somewhere else on a completely different service, telling us that users actually end up reusing passwords. Now that 17% I think is misleading. We think in practice it's actually much higher than that. Password reuse is much higher than 17%, but this is what our data from the crawling that we've done could back up. And then lastly, this is a Google presentation, so I'll just kind of give you the Google good news, right? So if you have a Google account and these credentials were discovered online, then what we will do is if we check and we see that those credentials actually work against the current active Google account, we will proactively reach out to you and try and secure that account and say, hey, we've discovered a matching password over here for an active Google account. Maybe you should change your password because something isn't quite right here. So because we have all of the information available and we can check these things against our internal databases, we have a way of reaching out to potentially affected users. And specifically in this slide, the good news is about 70 million of these accounts were proactively protected. So, a couple of stats to just start off the topic. There will be more of these before we get into the good news, I guess. Well, here's a bit of good news. So even if an attacker has your username and your password, it's actually not all bad news with Google and with many of the other, I would imagine, larger profile sites, because we see so many logins and so many events coming in from all across the web. It's actually for us not that hard to distinguish a legitimate login attempt from a fake one. We certainly do not only look at the username and the password being entered. So if some attacker out there has your Google username and your password and they present it to us, if that's an automated attacker trying to just kind of breach our systems by throwing these usernames and passwords, being valid at us, in over 99.9% of the cases, we'll not accept it. Even if the password of the username is correct, we'll say, no, we're not going to allow you in, because there's other things that signal to us this is not a valid login attempt. And at that point in time, we'll, of course, notify the correct or the rightful user, and we'll get them to change their password. And that's normally when you would see like a email coming from like accounts@google.com saying something like, hey, we noticed a suspicious login attempt from XYZ location. We blocked it, but we think you might want to take a look or maybe take action and change your password. So because we see so many logging events from all across the web, this is something that we can typically do. However, what I really want to talk to you about today, and what Stephen will talk about a little bit more later, is what about the 0.1%? The scale at which we operate, 0.1% is still immense, right? And also, what about other services on the web that don't have the luxury of seeing, billions and billions of different data records flying around that you can kind of, throw through systems and figure out patterns, which is good and which is bad. So what about the more surefire way of simply rooting out bad login attempts? And that's really what FIDO and WebAuthn are supposed to address. So we'll get to that. What are the sources of stolen passwords? Where do these things come from? So we've already said that we discovered about 3.3 billion of these online, and they mostly came from data breaches. So, data breaches are everywhere. Literally not a week goes by. Poor old Troy Hunt is selling his company right now because he can't even keep up with all of the breaches happening any longer, because every single week there seems like there's just more and more and more and more happening. So data breaches is like a fact of life. Lots of stuff happening there, and a lot of passwords and credentials, I guess coming from the data breach side. Keyloggers, age-old thing. We've seen this in movies for years and years. Some bad guy goes and installs some piece of software, malware on your machine, and whenever you type your password, it'll capture it and send it away somewhere else or save it on a file on disk. Yeah, these two are like, okay, it's like a problem, but by far, I think the largest, and I'll back this up with data in a second here, by far the largest issue when it comes to stolen passwords and account breaches online today is phishing. And really it's because it's so incredibly simple to set up, and it's so incredibly cheap to perpetrate, right? What is phishing? The phishing is when some bad guy sets up a website that looks just like the legitimate website. It's got the same logo, got the same form field, although some folks setting these things up don't really do such a good job in making things look, pretty similar, but you can do it. Like, it's not hard, right? Spend 10 minutes, copy the, HTML and the CSS from someone's other, original login site, put it on yours, you set it up on some URL. You don't even have to set it up on something that looks like the real service, right? Sometimes these folks run it on, .xyz.com. It doesn't matter. Like, you can run these services on something which doesn't even, the URL bar doesn't even correspond remotely to the original service, like a LinkedIn or a Google or a Microsoft or Amazon or whoever, because the problem is they know humans don't pay attention, right? We're busy. We want to buy that thing online. We want to check our email. We don't want to check URL bars. That's not what we're trained to do, and that's never what we're going to do. So the problem is phishing is so simple, because when we set up, and when a bad guy sets up these bad phishing pages, the chances that they're going to trick you into revealing your username and password out of your own accord, they're really just tricking you into getting you to type your username and password into this other field. The chances that they're going to get you to do that is pretty high. And in a slide later on, we'll look at exactly how high. First, I'll make you guess, but then we'll discover the real truth. So, account hijacking likelihood. So those three things that we've just seen on the screen. So if your account was part of a data breach, you're 10 times more likely to suffer an account breach, okay? So if your credentials were discovered in some data breach, some dump somewhere, your account suddenly becomes 10 times more likely to be breached. If you had a keylogger on your machine that is logging your username and password, you're 40 times more likely. This is what some of our research have found. However, if you are part of an active phishing scam and you go to a website and you reveal your username and password to some phishing dude somewhere, you're 500 times more likely to get phished. That's the lower bound. So for us, this really, this is the one thing that we need to focus on as an industry. Phishing is a real problem and it's only becoming worse and worse. So big problem. And we'll see a little bit later why phishing is kind of like doubly bad, because also if you do phishing right, or wrong, I don't know which way, but if you do phishing a certain way, you can even defeat most multi-factor authentication systems. So that really makes it pretty powerful, and it's also easy to perpetrate, which is why folks are doing it. So 91% of information security attacks start with phishing. This was from a PhishMe study beginning of this year. And then 80% of attacks on businesses include phishing. So, phishing is rampant. I don't think I have to say this over and over here, but basically phishing is a problem and we need to do something about it. And one of my last slides really that just shows some statistics or data here is we all worried about malware years ago. Like back when I guess we started capturing safe browsing traffic, and basically this comes from Google Safe Browsing, the public record. You can go to that same website and get the same graph. This one is just a little bit nicely formatted. You can see the amount of sites we're detecting that is hosting some kind of malware or potentially hosting malware, and sites hosting like phishing kits, or at least like some form of a phishing website built with a phishing kit. And back when we started taking these records in 2009, malware was rampant, right? Software that was meant to run on your machine to do bad stuff. That's what everyone was doing. Phishing was like, nah, whatever. It's curious because in 2016, finally, phishing overtook malware as the single biggest threat online. And then malware completely dropped away. And we can speculate why this is, right? Better AV built into your machines nowadays. Windows Defender, like folks are moving to Mac OS where, it's a little bit harder to do some of these things. I think there's a bunch of reasons for why malware is really dropped off, but at the same time, equilibrium needs to hold, right? There's still going to be bad guys wants to do bad stuff, and the option, the other side, the way that they can do this is with phishing, because it's so easy and it's so effective. So phishing is on the rise. So at this point, here's my quick obligatory interactive slide for the day. What do you folks think? If I sent a phishing email out to 1 million people, roughly, how many of those do you think are going to fall for my scam and will end up clicking on that phishing link, revealing the password?
I think 90%.
Okay, we've got it kind of like roughly here between the two edges. And the answer is, it is really kind of somewhere in between there. It's 43%, so I'd say about 1 in 2. Now, we're training our users. I heard of a company recently sacking some employee because he continuously fell for phishing scams. I can't even imagine how that would work, but sure. Really we can't blame our users. It's not their fault. The fault is in the technology, the fault is in the system. We need to find a better way of addressing this problem. So a study that we've done, very kind of light font there down below, but there's a study that we've done a couple of years ago where we can back this up, where about 43%, so about half of users will fall for a well-designed phishing scam. And then the other piece of that data is about 3/4 of account vulnerabilities were due to weak or stolen passwords last year, but we already said earlier, about, I guess, 80% of attacks started with phishing last year on the enterprise side. So this is kind of just to back this data up again from a different data source. So really, what is it that we need to do? So now the bad news hopefully is all done, right? Phishing, big problem. I think we've backed this up sufficiently. What can we do to try and address this problem? So the industry has collectively come up with a solution. It's called multi-factor authentication, and it is supposed to solve the woes of passwords, right? So multi-factor authentication is there. Of course, definition being like with a password, I enter something that I have in my head, one factor, something I know. With multi-factor authentication, I add another factor. And the factor is we normally think about when we talk about multi-factor is a something I know factor, which is a password. Something I have factor, which is like a token, maybe a phone. The third one is usually a something I am factor, which is like a biometric. So those are roughly the three. I know there's like a fourth one going out there tied to behavioral biometrics, but it's a little bit fuzzy. So I think I'm going to define it as those three for the moment. So earlier on, when we started with multi-factor authentication, we added, and we're kind of looking around and saying, well, theoretically this makes sense. I'm going to add another factor in. The other factor will be something that I physically hold in my hand. What is something that users all carry around with them? And before phones were even a thing, and before text messaging were even a thing, we started with physical hardware tokens, right? We got like some vendors to build us some little pieces of hardware, and this hardware will give a pseudo-random code out, and the pseudo-random code will be synced to what I know on the server side, and then when the user enters the code, I can infer that they have access to a particular piece of hardware. That's basically the crux here, right? There were different standards for doing that kind of stuff. Oath was one, for doing like TOTP and HOTP based on time or event-driven, one-time password-based solutions, and the world was fine, right? Things kind of worked, and it was great. And it solved many of the problems we looked at earlier. It solved password credential breaches. It solved keylogging. It even solved phishing to a certain extent, but we'll look a little bit further here in a second. Most modern sophisticated phishing actually sails right through many of these older forms of multi-factor authentication. But anyway, so we've got these options, and the idea was to prove that the user has a physical piece of hardware in their hands. And then came phones, and we were like, well, now we don't have to issue our users with hardware anymore. How fun is that? We can simply send them a message to a number that we know belongs to the user, and because the telco makes it so that only a certain user has access to that number, we can infer. So it's kind of like double inference at this point, but we can kind of infer that it's the right piece of hardware that the user holds in their hand. But that model kind of broke down. We know, like SIM swaps are something that can be done pretty easily, like the number porting scams that seem to happen every now and again. You convince your carrier, or someone convinces your carrier that they're you, and they then give your number away to someone else. So you're placing your trust in another third party, which, depending on the country, depending on the laws, it's not something that you can always factor into your risk modeling. So that's the one problem. The other problem is the technology is kind of old and a little bit brittle. We've all heard of the SS7, and sometimes these things get conflated. We've all heard of the SS7 stories, and if you are sufficiently privileged in carrier networks, even as an outsider, it's possible to reroute some of these messages too. So at that point, the whole I have something physically in my hand totally falls flat. So at some point, and even with NIST, started saying that, hey, maybe we should get rid, or at least start minimizing the use of SMS and voice for multi-factor authentication. It's still better than just a username and a password. Don't let anyone dissuade you of that. Like, you have a username and a password, adding SMS or voice capabilities to do multi-factor is still a step up from there. It's not a step down. But certainly there are other things that we could also do. Then came the authenticator options. Google Authenticator is one example. Many, many others exist today. You do exactly what we've done with the physical piece of hardware that we have in our hands, but it's all software. You download an app, things get synced, and then the app will give you the code. That's cool, right? Then we wanted to do things a little more simply. So then mobile push came along, and we said, okay, well, this way we're going to just send you a mobile push message to your phone that's registered. If you can click the yes button, that means you own the phone or have access to it, and because of that, we're going to give you access to the website. If you think about it, it works exactly. It's got the same properties as the Authenticator app running on a smartphone. It's just a little bit simpler, right? Just click a button and you're signed in. The problem with all of these, and this is something that I'm not going to go into too much detail, but I do have one slide, so you can kind of maybe check your mail or something if you're not interested in that much detail, which I decided to add in last minute kind of here. But I do have one slide that talks a little bit about the anti-phishing properties and why why we have this phishing resistance in the FIDO security keys. But essentially, up until that broken line there, all of these technologies are technically phishable. And the way that would work is, if I'm a bad guy and I set up a website that asks you for your username and asks you for your password, that bad guy can just as well ask you for your backup codes. It can ask you for your SMS OTP code. It can ask you for your TOTP code. Why not, right? If they need it, why don't they just ask for it? And you're going to go to your phone and click generate and open your app and type the OTP code in there. And hey, they're going to get your OTP code. Granted, the OTP code only, it's valid for, 30 seconds typically. But these folks are quick, right? They will automate this, and they have automated this. There's kits available right now where automatically, upon you entering that code, they will try and log into the real website, they will obtain a session cookie, and at that point they're in your account, right? So it's not someone physically sitting at a keyboard. This stuff is all automated. Now you're going to tell me, but what about mobile push? There's no code. That's true, but if we think about the model here, like the bad guy is literally in between you and the correct server. So it's me, I'm the user, I've got some bad guy, and I've got the service I'm trying to log into. So what will happen in this case is I will go to the phishing website, I'll type my username and my password. The bad web banking website or bad website will immediately send my credentials, my username and password onto the real server. The real server will trigger the out-of-band push to my phone. I'm going to get the push. The push will say, are you trying to log in? And I'm going to go, yeah, sure, I'm trying to log in. This is what I'm doing right now. I'm going to click yes. And instead of that server logging me in, they're going to log the bad guy in. Because to the server at the back end, these two things are indistinguishable. Yeah, we can show the IP address on the phone where the user is trying to log in from, but really who knows what their IP address at this point is, of their home ISP. Like, I don't know. So the point is, all of the technologies up from the FIDO security key side to the left, they're all technically susceptible to phishing. And it's not by accident that we discovered that FIDO security keys are phishing resistant. They were built with that explicit goal in mind. Phishing is the problem that we wanted to solve, and the question was, what can we come up with that can actually address that as a problem? So, a little bit of marketing. I'll just leave this right here for a moment. So then comes the security key, right? And there are many different security keys out there today. Many vendors make great security keys. A bunch of them are here today. Google also came up with one, which we kind of sell through our channels, but essentially they all do exactly the same thing. They implement the FIDO protocol, which I'll talk about very briefly in another slide here. They implement the FIDO protocol. And what the FIDO protocol does is the FIDO protocol makes sure that the user is not being phished. At the fundamental level, that is what the FIDO protocol first and foremost does. Yes, the security key also contains a piece of material. It contains a secret that proves to the remote website that you hold the key in your hand. That's the basics of multi-factor authentication, right? I own a piece of hardware. So that's in there and that goes without saying. But the security key does something more. The security key also verifies that I'm on the correct website when I'm trying to log in. And that's kind of the crux, and we'll look at that in a second here. And now you're going to tell me, well, security keys, like carrying around physical factors, kind of so last year, we didn't want to do that. Well, the goal here was never to make the whole world carry around physical keys. The goal here was to give the world a phishing-resistant, strong authentication protocol. And that's why earlier this year, we announced something called like the built-in security key in your phone, where we took the FIDO protocol, which is what makes the communication between the laptop up top and the security key work. And over there, it's through USB. You have to physically plug the two things into one another. That's how you establish local presence. Then at the bottom end there with the phone option, we also did this over Bluetooth. And actually, Bluetooth has existed in FIDO for quite some time. You actually get security keys like the one up top that works over Bluetooth. Local proximity, again, very important. Being able to know that these two things are physically co-located is critical. And we've kind of extended on that theme a little bit and said, well, if the laptop has Bluetooth and the phone has Bluetooth, why can't these two things just communicate and make it work? Well, one of the reasons it took such a long time is Bluetooth pairing is hard, and it's not like no one wants to do it, and it's kind of horrible. So what we really wanted to do is we wanted to come up with a solution which required no Bluetooth pairing between these devices, but still makes it secure. And that's what we've come up with. That's something that we took that back to the FIDO Alliance, and we are busy standardizing that. And hopefully we will see more properties apart from just Google actually embracing that technology as a way to do strong two-factor authentication. So there, it looks very much like the push-based authentication that we're all used to, but instead of sending things via the cloud, there's local connectivity between the laptop and the phone, and that really is the crux of the anti-phishing or the phishing kind of defeating technology in the FIDO protocol, which I'll talk about here. So how security keys work? Let me briefly, show you one slide on this, and this is the last piece before I'll invite Stephen up here. So essentially how security keys and the whole FIDO technology in general work, and if you want to think about how the phone as a security key work, you can literally just in your mind replace that physical security key with a phone, right? So the first thing when I'm trying to sign in, what will happen is the server will send me a cryptographic challenge. Cryptographic challenge is like a random number. It's just to ensure freshness. It's like someone can replay this login attempt. So some challenge will be sent from the server to my phone. My left-hand side there, that's my phone or my iPad or whatever. I don't want to sign in. At that point in time, the phone will locally talk to a component on the device itself, and it'll do kind of like a caller ID thing, right? It'll say, well, someone is asking me to do something on a security key. Who is that? And in this case, on the web, the who is that is the actual URL up top. So this thing is saying, oh, it's google.com who's asking for a challenge. So then that platform component in step 3 will pass the challenge that I got in step 1 together with the google.com, which the server didn't send. The device locally figured out who the caller was, so it looked at the browser and asked the browser, hey, what website am I on? And it said, I'm in google.com. So I send all of that information to the security key. And then very, very simply, the security key, whether it's a phone or a physical one, doesn't matter, will perform a cryptographic signature based on some material that the key has in it, which is unique. And by the way, the server doesn't know the exact material. We're using asymmetric crypto here. So the key has some private key that it stores. The server knows the corresponding public key. Don't have to know all that. Basically how this works, when I send that signed challenge back all the way to the phone will simply relay it back to the server in step number 6. And when the server receives it, it looks for a couple of things. Firstly, it looks and sees if the challenge is still the same challenge that it sent in step 1. If that's good, check number 1. The second thing is it looks to see what the origin, that caller ID party was in the message. Is it actually google.com that the user would be interacting with? Because that's what the server would expect. If I'm on a phishing website, it will not say google.com, it'll say something different and the login attempt would be rejected. So that's the step number 2. And then step number 3 is the whole thing actually cryptographically signed using the key that the server would have expected? Security keys, I omitted this step in here, but security keys require some prior registration step, right? At T0, you have to actually, when you buy your new security key, go and tell Google or the service about it. That's when the server learns about your public key for your private key that's on your security key. And at that point in time, we establish this relationship. So we kind of assume that this happened already in this particular step. With your phone, it's when you go to your Google account details and you actually add your phone as your security key onto your account. That's when the registration happened. That's when the server learns about the public key. So 3 steps, right? Check the challenge, check the origin, make sure it's signed correctly. That's it. It's very simple. Why hasn't the whole world adopted it yet? Well, getting hardware and all these other things and getting the support right. I mean, there's a lot of burden here. And that's why we are working in 2 standards bodies, and Stephen will talk more about this. Between the server and the phone, we kind of broke up the standards a little bit. If you are a web server and you want to support this great newfangled WebAuthn FIDO technology, all you need to learn is the W3C WebAuthn API. If you understand that, then you can build this technology into your server and into your websites, and that's the protocol that will communicate between the server and the client. And we now have support in pretty much every single major browser. This is the first public event that we can say that. We've got support in Chrome, we've got support in Edge, we've got support in Firefox, and at WWDC, I guess 2 weeks ago, Apple announced that they are bringing support to Mac OS X, and I think that deserves like a round of applause here. So that's really fantastic. We are really kind of in the home stretch here. So that's fantastic. And then we have a completely separate protocol, which you really shouldn't be too much concerned with unless you're actually a vendor that wants to build security keys. And that's the kind of second layer down there, which is how does the phone or the computer or whatever actually communicate with the security key? But these 2 things are completely abstracted. So if you are a web developer, you do number 1. That's what you have to concern yourself with. The second one is only necessary if you actually want to get into the business of making security keys, and that's standardized in the FIDO Alliance. With that, I've said too much. I stayed too long. I will hand over to Stephen.
Okay, thanks, Christiaan. So I'm Stephen. I'm a product manager on the Chrome team, with Christiaan's counterpart working on building this technology into the browsers and making it available to developers. So hopefully, Christiaan has conveyed in the first section here some of the problems that users are facing and developers have to deal with. And in this last section, we're going to cover the technologies that you can actually use, implement for your site or your service, and how they look to users. So my team at Google is building the technologies into Chrome, especially into the web platform, so the underlying set of APIs that are what constitute Chromium. And in turn are used by all of the browsers that are built on top of Chromium, and as a standard are hopefully implemented then in other browsers. And Christiaan just mentioned the long list that we have of other browsers that are currently supporting this API, which is WebAuthn. Okay, so WebAuthn is the developer-facing API available in a browser that allows you to talk to authentication hardware. And so that's the security keys, potentially, as Christiaan discussed, but it also can include things like built-in sensors in a device, so a fingerprint sensor that's part of your phone, as well as some of the novel form factors, things like using phones as security keys, as Christiaan mentioned. Okay, so standardized API, part of W3C, available in basically all browsers, and has historically been done as part of the FIDO Alliance of companies to get it into the standards process, and now an open web standard. Okay, so architecturally, where does this all fit in? So what we're going to be talking about in this last section is the interaction between the browser and a developer's website or web server, so-called relying party, as you'll probably hear in lots of talks today, and not so much the left side here, which is the interaction between the browser itself and hardware, which is still under the FIDO Alliance, and how security keys and new form factors are interacting with the browser or the phone that you're on. So I think one thing to appreciate here is that although technically interacting with an authenticator can take a variety of different physical form factors, from the user's point of view, there are two primary use cases, two primary journeys that the user is going to go through. And so these are the things that you probably encounter yourself as you log in and use services online. And the first is setting up a new device, so logging in the first place and setting up your account on, say, a new phone. And to do that, you also often have to go through multiple steps, use the multiple factors that Christiaan mentioned. And then there's this case where once you've set up a particular device, you're often going to come back to access potentially sensitive data, like in a banking application, and you need to prove that it's still you. And so the thing to keep in mind here is that WebAuthn supports both of these interactions. We're going to focus actually on the latter one. This is probably the more common one. You can imagine using your device on an ongoing basis and re-authenticating. It's only when you get that new device that you'd really need to bootstrap your credentials. Okay, so one common question that comes up is people have seen similar functionality natively on Android for some time and often ask, well, what's the relationship between these FIDO and WebAuthn APIs and what has existed natively? And so in Android, we have provided for a long time APIs that give you direct access to key management as well as biometric hardware, keeping in mind that in all of these interactions, whether it's WebAuthn or direct native APIs, the developers are not actually accessing the biometric data directly. The biometric sensors are used to unlock keys that are then used in the authentication protocols. And so these APIs have existed on Android for some time, and we now have another layer on top offered as part of Play services that allows you to interact with these sensors, with this key management, but do so in a FIDO compliant way. So the data that you get back adheres to the FIDO protocols, and you can use with your FIDO servers in the same way that you can use this information from WebAuthn. Okay, so let's take a look at how this actually looks for someone who might be using a site or a service. So we've got Elisa here, and imagine that Elisa is coming to her bank. So she has an existing account here, and the first thing that the bank's going to need to do is to log her in, to authenticate her using the traditional mechanisms. So that would typically be a username, password, maybe a one-time code if this is a new device. And once this bank, TriBank here, has figured out that this is in fact Elisa, we have the opportunity then to enroll one of these FIDO authenticators that we've been talking about. And so we'll start with the fingerprint sensor. And so what the site is showing at this point, once the user is authenticated to the service, is a promo to enroll an authenticator like a fingerprint sensor. And so you can imagine a couple of different variations of this, perhaps at the time that Elisa created her account in the first place, or perhaps in a flow where she's setting up a second factor. This enrollment promo could be tailored to the particular use case that I mentioned earlier. So this particular one is setting up a local sensor on the device to help authenticate Elisa when she comes back. And so there's a few details here that as a developer you'll need to know about when you're calling the API. So the first one is checking whether the device that she's using even supports one of these sensors I mentioned, like a fingerprint or a face scan or something like that. Samsung devices have iris sensors to authenticate the user. And so there's a handy but long-winded name in the API is User Verifying Platform Authenticator available that you can use to check that this device that your user is on supports this type of interaction. So if that's the case, then you can issue one of these create credential calls to the API. So as I mentioned, this is a built-in browser API. You don't need a particular library or anything like that. You just call from the browser itself, navigator.credentials, and in that namespace, there's a create command, and you can pass in some instructions to the browser about what type of credential to create. So the things to know here are that in this particular use case where we're trying to have the user enroll a local sensor, we want to make sure that this is a platform authenticator, so that means one that's built into the device, and it's one that can do user verification. So those are the second and third options that you see here. And one other thing that you might want to do just from a user experience point of view is prevent the user from re-enrolling if they've already enrolled this device. And so once you have made one of these API calls, you'll get a credential back. So that's the object representing the user on this device. And you can store that on your server and supply it next time if the user tries to enroll again, just to prevent the user from enrolling the same device twice. So those are the details of the API call. But the interesting thing then is how you use this. So when Elisa comes back to the site next time, knowing that this person has enrolled a local platform authenticator, you can prompt her to use that authenticator to prove that it's her instead of entering the username and password or whatever credentials were provided last time. So you see that this platform authenticator inherits the same strength as whatever mechanism you used originally to authenticate this user. So in this case, she's prompted to touch the fingerprint sensors. That's what this device supports. Keep in mind that this is an OS level function, so the browser talks to the Android system and determines what sensors are available on this device. You don't need to know the details of whether that's a fingerprint or iris scan, but the end result is that if everything checks out and this is the same person, the keys are released, and the user is then able to sign in passwordlessly. She doesn't have to re-enter her password again on this device. And so you've probably seen this before in native apps. You've downloaded your banking app and enrolled your fingerprint. This is now available on the web through an open web API. Very exciting and nice to see this finally come to the web. Okay. So behind the scenes here, similar to the create call, there's a get call. It's got similar parameters here, so making sure that you're asking for the credential that was previously enrolled and that you need the user to be verified. And the end result of that is the credential you use to log in. But of course, people are not using just the mobile websites. You can imagine how Elisa here might come to the Play Store, download a native app, and want to sign in on this device again. And so you'll see that, fortunately, we have recently offered APIs in Play services that will allow you to do the same thing through a native app. Okay, so in this case, we're interacting with a native app. Same situation, user starts off by saying who they are. Once we know who they are, we can challenge the user to use the credentials that have already been created on this device. See the fingerprint prompt here. And the same thing, she'll be signed in without needing the password. The code here is very similar. This is, of course, native Android code. If you just search for FIDO Android API, you'll see the documentation online. But it's similar parameters, similar result. And I think the interesting piece here is to see how this has played out for some of the people who've actually tried it in the wild. And so we have some external examples here. This is Yahoo Japan, who implemented this on their mobile website. And the end result of users coming back on mobile web and not having to enter their password again is pretty dramatic. It's over a third less time spent in the login process. And we've also seen this for Google's own properties. So we have one, passwords.google.com, where there's some sensitive content that we need to re-authenticate the user. And here we've started to roll out a process by which a user can enroll and use their fingerprint instead of a password. And you can see that there's a pretty dramatic reduction in the amount of time and errors that users encounter when they're trying to authenticate. And so if you look a little bit closely at the data here, so on the left is the situation when someone can biometrically re-authenticate. The blue bar there represents the success proportion, and the red and yellow there are a couple of scenarios where either the user skips or has to set up the fingerprint. And you can see that the majority of people successfully authenticate right away. That's 90%. On the other hand, if someone has to re-enter a password, you can see that ultimately, 2/3 of people do still get in, but there's this significant portion, a quarter of users, who are struggling and ultimately end up failing. And so you can imagine the business value to your company if you have users who are no longer having to spend the time or the effort, no longer having to send you support inquiries about forgotten passwords, and so on. And so the hope is that you can take this, extend it a little bit, use things like security keys with your website, re-authenticate users biometrically, and really get people out of the business of having to deal with passwords. And so there's a few things that you can take home from this talk today. These APIs are live. They're available to anybody who is running in the latest versions of Chrome and the other browsers that we mentioned. To get started, you do need to accept these types of credentials on your server. So you'll have to follow the documentation for FIDO, set up your servers to accept these credentials, and then take the information that you get from the WebAuthn API as the user interacts with your service, store that on your server, help re-authenticate the user, and put them into a state where they can passwordlessly be logged in. And keep in mind that this does work across native and web apps. There's a little bit of work that you have to do to make these two work nicely together. And so there's some instructions here about how to link your two properties together. With that, I think we are going to take questions for the last 10 minutes. And Christiaan can probably come up and handle that any are in his domain. Go ahead.
Oh. Do we have mics? Because I think it's going to be no handhelds? Oh, we have no runners.
Okay, we can just repeat the question.
We have a runner. Well, thank you for volunteering. That's fantastic. All right.
Okay. So two things, and kind of interested in seeing what Google is doing about this is, in an enterprise market compared to consumer market, the idea of not doing identity proofing or using a weak credential to tie your FIDO 2 account to make it a stronger credential is problematic. So any thoughts on that? How does organization, because they want to step up the, whether it's the level of assurance, whatever the compliance needs they have. And secondly, is the management aspect. Right, this is great for even U2F. Right, it's good for 1-to-1 ratio of application or my Gmail account or these things. But in an enterprise, when an employee leaves the company or they have data that need to get to because something happened or there's a court case, whatever it is, the whole organization's dealing with centralization for PKI or for other types of authentication mechanisms they were implementing or using. They want to use FIDO 2, but the main challenge is the management aspect of it.
Fantastic question. I'll try and take Stephen probably have thoughts on this too. I'll give you my thoughts on both of those. The first one being identity proofing. It's still a giant problem. We haven't set out to try and solve that or address that in FIDO because it's more of like a workflow issue, although now there seems to be interest in trying to tackle that. I'd say two things. The first one is, in an enterprise environment, in some cases, face-to-face is kind of still the way to do some of these things. And if you really want that level of trust, issuing a key and physically looking someone in the eye might be one way to solve the problem. Certainly not scalably, but it's one thing that you can do. On the consumer side, the things become a lot more interesting because you can start to build trust and credentials. Think about this one, right? Today, I buy a new iPhone. On day 0, or a new Android device. On day 0, I reset myself up type in my username, my password, my weak credential, whatever. Then I get stepped up to a stronger credential using my fingerprint. And then over the next month, 6 months, 8 months, 12 months, the other party starts to gain confidence, because if I'm transacting on this device and everything seems to be fine and no one seems to be phoning the bank's fraud department, they start to build trust in that credential on this device. 2 years later, I buy my new phone, and I have to start all the way back from zero again, and all that trust that I've built up in the credential is lost. What we want to try and do with a solution like this is to say, well, can that trust that I've established in that credential, can that trust be transferred? What if that credential on the phone could be transferred to my brand new device in a secure way, so that now that credential doesn't start from T0 again, but it's now T2 years plus old, right? So at that point in time, we can bootstrap kind of from a least secure or a less secure credential to a secure one by using time as the thing that changes and kind of gives us more confidence. Certainly that doesn't really work in the enterprise environment, because from day zero the user needs to be, set up to go, and that's where like some kind of a physical interaction or altercation might still be required. But in the enterprise or in the consumer world, I do think that there is a way to kind of move us slowly into the world where we start building more trust in these credentials by doing nothing different than we are doing today, but just kind of using time as that one kind of axis along which we build trust. The second one, we'll get some time, PKI one. I mean, we can talk about this offline, but I think FIDO is a lot easier to manage than traditional PKI solutions, because the way that FIDO kind of works and plugs in is it plugs in centrally in your authentication solution. So one thing that you do need is you do need some kind of an SSO. I would say and we're at the SSO conference here. So you do need some kind of a single sign-on solution. And if you implement FIDO centrally over there, and that's where your tokens are tied to, then even if the tokens are lost or the user goes away from the company or whatever, there's a very easy remediation plan. I mean, for our own identity provider, for Google Cloud Identity, there are certainly easy ways that admins can recover from that situation. User is lost, token is lost, I need to get data access back again. But I think that's a function of the identity provider rather than the actual applications. Stephen, anything?
Not too much to add.
Okay.
Go ahead.
I think I speak loudly enough.
Yeah.
For WebAuthn rollout against the various flavors of Chrome,
Yep.
I know you're doing really well in the Android space. What do you expect from Chrome desktop? And I got to ask also in the iOS space, any movement there?
Okay, so the question is about the rollout of Chrome and the support for WebAuthn. So the ones that are already out are actually Android and desktop. So on all versions of desktop that we support, so macOS and Windows and to some degree Linux.
BLE in addition, Bluetooth in addition to USB and all the various flavors.
Yeah, so the dimensions here are, well, there's several dimensions. So the first is the platform that you're on, and then the second is the different physical transports that are supported for the types of authenticators. So there's the built-in ones like fingerprint sensors. There's ones that communicate over USB, that's the traditional plug-in security keys, and then there's some of the newer ones with Bluetooth. So Bluetooth support is in the builds. We are working on debugging some issues, make sure that it's reliable enough for ordinary consumers to use. We do have the Bluetooth support for the phones as security keys, the Android devices out already in the wild. So it's a matter of time. We're expanding the support to the different platforms. Yep. So on iOS, we don't have a huge presence other than the Chrome app itself. We've been giving that some thought, but I think the onus is mostly on Apple at the moment to support in their browsers. That's what most users will interact with on iOS.
So I had two questions. First one, in regards to enrollment for platform versus roaming credentials.
Yep.
So if you on like a desktop where the user might have one or both, is the recommendation there to have both as an option for the user and kind of brand those properly? I know like Microsoft has, they brand it as Hello or Windows Hello for theirs, but that doesn't make sense obviously for other platforms. And then the next question is for the cloud-assisted Bluetooth Low Energy.
Yeah.
Is that available for like enterprise use cases and stuff, not using Google, or how does that work? Do you need to develop an app for your users to be able to do that Bluetooth syncing or not syncing with their PC?
Okay, so the second question first. So support for the using like a phone as a security key, essentially, that only works with Google accounts right now. We are going through the standards process, as Christiaan mentioned, to make it available to any third party. So we hope to have that out sooner or later.
We
but
have a
standards
test
take some
build
time.
if you're interested. Like there's things where we're going on that path, but I'm hesitant to give exact dates right now, but it's certainly something we're working on, as Steven said. Yeah.
Yeah, exactly. So I've heard a lot of demand for that. We showed this off at I/O, and many people came by and said, "Can we have this for our site?"
Yeah.
So we're well aware of the demand, but it does take some time to go through the standards process. So then your first question about cross-platform versus a built-in authenticator. I guess in my experience, I think the important thing is to try to figure out like what use case you're building for, which user experience, whether you're trying to locally help a user sign back into a site they've been to before, so you need it to be a platform authenticator, or whether you're trying to build an experience where the user is going across devices to bootstrap a new one, in which case you want to make sure that it's a cross-platform authenticator. So tailoring the parameters to the use case that you're trying to build for.
Let's take that one last question over there.
So in case of web authentication, we saw that a browser is source of truth. The browser is passing the domain to the authenticator.
Yep.
What happens in case of the native in the native app?
So we said browser, but really what we meant is kind of platform. So if you think Android or you think Windows Hello, there is not actually the browser making that decision. The platform is actually the one that's making that decision. Everything in WebAuthn is based off of domain names. So we do need a way to map, at least on Android, as Steven suggested, we need a way to map an Android application to a actual domain name, and for that we're using Brandmaster or the asset links mechanism. You can read a lot more of that online, but essentially what we're doing is we're using a mechanism to map a publisher's kind of name, the developer name of their and whoever publishes the application. We map that through to a web URL so that it can be used in WebAuthn, but the platform is the one that does the enforcing in that case. Yeah.
Yeah, and so the details are actually in that last link there.
All right, folks, I think we are being asked to run away, so thank you. Thanks for listening.